My name is Gottfried Wasser. I'm the rebel geologist and I am your instructor, right? I've been a consulting geologist for many years and have also worked for as a staff member for various oil companies over the years. Uh, the logo there on the left-hand corner, the bottom corner there, that is my consulting company, Eucalyptus Consulting Inc. So as a consultant, I performed reservoir studies in southern Alberta and in Southeast Asia, ranging from the Belly River Group, the Glauconitic Member, and the Pakisco Formation in Canada to the Talangaka Formation in Indonesia. I also presented courses like this one, but then in the classroom setting instead of virtually. And I did field trips. I taught in Canada, Indonesia, and Egypt. Since 1979, yeah, oh shit, that's so long ago. I have worked as a petroleum geologist, or better, I call myself a reservoir geologist because I focus a lot on describing what the oil or water reservoir is that we're working in, that we're dealing with. I have an MSc in sedimentology from the Dutch State University of Utrecht. You may have noticed my accent, very similar to Dutch soccer players, right? And that now you know the reason. In 1992, I started my geological consulting company, Eucalyptus Consulting, and since then, I was employed by several oil companies or petroleum companies, but I also worked for them as a consultant. I retired several times during my career for various reasons, and then I got bored, and then I tried to do something else. I became a realtor, as you see on the next slide. Nah, that was not that good. And then I unretired and started working again. Then I was disappointed in my latest employer and resurrected Eucalyptus in 2016 again, together with some friends. Really, by that time, I had enough of bosses, and together with several previous co-workers, we revived Eucalyptus and are active until this day. Amen. Amen. Omen. Omen. Here is me on one of my retirement adventures being a realtor. So one of my previous employers encouraged me to create a geology course for engineers. I did it first for my earliest employer, Pan Canadian Petroleum, which later on became Encana. And then when I decided to retire from my CNRL employee, which was really one of the best parts of my career, to be honest. But when I decided to retire, that was about 2006, they asked me, can't you teach our engineers some geology? And I say, yeah, I've done it before. I can set something up for you guys and then we'll teach it in-house. And that's how this course started. And it takes you from volcanoes on the ocean floor to the thrust faults of the Rocky Mountains in Alberta, right? And to the log analysis or petrophysics, as the log analysts want to call themselves. We are petrophysicists. And sandstone reservoirs we look at in the subsurface. The course originally was associated with videos, but because of royalty issues, right? I cannot show those videos except if they are available as YouTubes, and then I will give you the link. Some of those videos are available through trailers, and then you can decide whether you will want to go and look deeper into it. I mean, some are truly sensational, so it might be worth your while to do that. Right? I will try to give you as much information and maybe show you part of these videos as part of this course. We'll be seeing also carbonate reservoir examples, but you have to watch out. I'm a sandstone specialist. I'm a clastic sedimentologist, and that is my forte. So I won't give you the same details when we show you a case history on carbonates as I will do for the sandstones. And I hope that during this course you will get some good insights, and of course that you'll have a lot of fun as well. Okay, the course was originally a 3-day course. And the first day we would do this introduction, and we showed you volcanoes on the bottom of the deep sea. Then we talked about igneous rocks, so that are rocks related to fire, right? If the rocks, the molten mantle of the earth, right? If that just intrudes into the crust of the earth, and I'll show you later on what it is like, then we call them plutonic rocks. On the other hand, if they flow out over the surface of the continents, or when they're on the bottom of the ocean, then they have different cooling patterns, and they create different types of rocks, and then we call them volcanoes. Oh, also when those plutons, these plutonic rocks, impregnate the crust of the earth, which is often of a different material, then they can heat up the surrounding rocks, partially or completely melt them, and then form what we call metamorphic rocks. And that's what we're going to talk about following the igneous rocks. And then we're going to get more into the field of petroleum geology and sedimentology, because most rocks that we work with in the oil industry or the gas industry are not igneous rocks. They are what we call soft rocks, while the igneous rocks are sometimes referred to as hard rocks, right? Maybe because the soft rocks are easier to weather and erode. I don't know. Maybe because the hard rock geologists have a piece of a concrete in front of their head, and we petroleum geologists are quite sensitive, right? Well, maybe not. So as part thereof, we're going to talk about stratigraphy, the way that the layers of rocks are organized in the subsurface and also on the surface, to be honest. No, we're not going to have a virtual lunch. And then after lunch, I'll give you a case history, a regional study that I did in the Jurassic and the Lower Cretaceous, and you'll find out what it is, of northeastern BC in Canada. And once we've done that, then we're going to go a little bit deeper in sedimentology, how sand grains and animals form limestones and sandstones and shales that we call today sediments. And that is the main group of rocks that contain those hydrocarbons. And also a lot of water, a lot of aquifers are in there, right? So we're starting out talking a little bit about carbonates. And then because I'm lost for words, we'll show you a movie, Coral Reef's Adventure, or part thereof, whatever I get away with. Sandstones, that's the second part of the sedimentology group, also referred to as clastic sediments, are often formed in the marine environment. Carbonates like reef deposits are of course marine as well, but shorelines like the Dutch coastline, right, or the dark sands of Hawaii, those are also marine sands, right? And then we have fluvial deposits. And then on the border, on the edge between marine and fluvial, we have deltaic or estuarine deposits. Well, I nearly skipped a day, but on the second day of the real course, we did a field trip to the front ranges of the Rocky Mountains in Alberta. You cannot do that, but what I was planning to do instead was making a series of videos in the field to show you the same thing, right? And then probably each stop on the field trip is a video by itself, right? So it won't be very long, maybe 10 minutes or 15 minutes, and maybe some footage from driving to the field trip area, right? And you can admire the beautiful scenery. And then the third day, we're getting back more seriously, and we're going to talk about the architecture of sandstones and carbonates. How are these rocks organized internally when you look through the microscope, for example? And we're describing these rocks two ways: as cuttings descriptions. When you drill like a Black & Decker into a stone wall, right? You drill in that hole in there, and guess what? You see all the dust coming out. Well, when you drill an oil well or a gas well, the same happens. And we call it then drill cuttings. And they're small fragments of the rock that have been loosening up and broken apart by the drill bit, right? Which is a lot larger than the bit on your Black & Decker, I can tell you that, right? And then also we can use hollow drill pipes with the catcher at the end together with the drill bit. And then we can drill out a column of the rock, right? The bit is hollow basically, and the rock gets caught in the center of the bit up the drill pipe. And then when we bring them to the surface, you have a 6 or wider inch diameter inch core that you can analyze in all kinds of ways, right? And that's very, very useful, right? Because that's the best you can do seeing your reservoir that is a kilometer or two below the surface of the earth, right? So then we'll show you another case history because we want to keep it practical, right? So we start out with a pool that as a junior geologist I put on water flood in the 1980s, and it's called the Alderson Upper Mineville Z pool. And then we look afterwards, 20 years later, as to what was right in that study and what is wrong. Because geology, like any science, works with data, and how scientists perceive data changes over time, and the hypotheses or the theories as to how those rocks were formed and other parts of geology, they are nothing but interpretations. And even data, you will learn, is something very questionable. If you want to listen to a real distrustful person regarding data, then just go visit Scott Adams and his coffee video, his daily sip there. At least you will enjoy the coffee, right? But he's right. I mean, a lot of data is not as straightforward as you may think. And in petroleum geology, or in geology in general, we're trying to extrapolate what happened 4 billion years ago or 100 million years ago. You think we were there when this all happened? So, no, there's a lot of interpretation involved and thinking, which is pretty painful, at least for me. So, then we're going to talk after the Manville case history. What makes a reservoir tick? What are the mechanisms that oil and gas flow through a rock, and how is it even possible? The rock must have some kind of an internal plumbing, right? And that is what we do when we make thin slices of rock, so thin that you can literally read a newspaper through them. So just 60 angstroms or so thick. And then we put it under the microscope, and then we shine polarized light to it, and then we can make a lot of observations as to how this rock is organized and why it flows. Why it flows oil, gas, water, etc. And once we have a little bit of that understanding, we're going to go back and look at the Belly River reservoir quality, a case history of the Belly River, another pool I worked on. The case histories that you see are mostly projects that I have examined over my career, right? And some are pretty old and others are relatively new, right? So then we revisit again the question, what makes a reservoir tick? And we do that now not by observing the rocks, but by observing what you can learn from logs, wireline logs. These are geophysical tools that measure in the wellbore along the geological column the resistivity, the density, the neutron emissions, right, and the gamma rays of that were radiation that is emitted from those rocks. And we can use that together with what we've learned from our cores and cuttings to interpret what the rocks in the subsurface are like. And then we do two final case histories, a regional view of tight gas in northeastern BC again, in the Mink Grizzly area. And then we're going to a conventional reservoir, the lower mantle of Horsefly Lake in southern Alberta. And that is the outline of this course. I might split this video in two because it might be a bit long. And then we start with the subscriptions on the main site.